Hello, this is Dr. Mahagaonkar, Faculty of Mechanical Engineering Department, Government of I welcome you all for the part 2 of the Model 1 Internal Combustion Engine. So in the today's session, I'm going to take you the basics of thermodynamics, that is, what are the different properties, what is first law, what is second law, just a review or revision of what we have studied in the basic thermodynamics. So now let us, we will go for the model part 2 of the model 1, internal combustion engine, basics of thermodynamics. So in this we are going to study just to have a revision of thermodynamics properties such as pressure, temperature, volume and density, the intensive, extensive properties, and then we will go for the system, subsystem and the control value. After that we will discuss what is open loop and closed loop system and isolate system. So first of all, before going for the zeroth law of thermodynamics, so just to have this. So in the first one, that is the properties. We have already studied the different properties, thermodynamic properties. These are nothing but the pressure, temperature, volume. So what is a property? That means it is just if you have any gas is there, a particular state. So it has got particular pressure, temperature and volume. So that state, so that is known as the properties. It is a state, that is at particular state, what are its characteristics, how we can recognize it, right? So this can be seen by through the properties. So there are two kinds of properties. One is the intensive property and another one is the extensive property. Intensive property is one, it does not depend upon the mass, whereas extensive property is one, it depends upon the mass. If, say for example, if I take volume, it depends upon the mass of the system, right? So that pressure and temperature, if I take pressure, it is an intensive property. It does not depend upon the, it is per unit area, force per unit area. Whereas if I take force, it is an extensive property, whereas pressure is an intensive property. So that is Newton per meter square, per unit area you are. So that's why it becomes an intensive. Similarly, as an example, we will go for the second one, that is density. What is density? Density is mass per unit volume. Mass per unit volume. So here it depends upon the mass, but it is per unit volume is the kg per meter cube. So hence what we can say here, the density, it is a property of a system. It does not depend upon the mass. Whereas the density actually, if you if I want to take the volume, so then if I want to calculate what is the mass, so mass is equal to the volume into density you are going to. If you know a particular volume and multiply the density of that substance, okay. So hence that is called a property of the system. So it depends upon the temperature. So it is not always constant. Density of air, if you take it, at near to the Earth's surface is different. As you go up with a meter of height, So that means that with the increase in temperature, the density of that air will be different. So, but approximately what we are saying, density of a particular thing that is at constant normal temperature and pressure, it will remain same. So hence that one we can take it as a property. But in thermodynamics, sometimes we are using, say for example, if you are taking an ideal gas equation. What is ideal gas equation? It is PV, pressure into volume, is equal to mass mRT, where R is the gas constant and T is the temperature. Okay, PV is equal to mRT. If I take V by M, yeah, then you will get what? Volume per unit mass. Or um, if I take this V on this side, then I can take it equal to PV is equal to rho into RT. Rho into RT. RP by rho is equal to R into R. So that means, so that thing I can explain it with using this board. So with using the board, we can explain you in a better way. So let us say you consider this ordinate as a pressure, as an ordinate, and V volume. It is in abscissa. And this is in Newton Pascal or Newton per meter square. Right? So that is the unit of Pascal of this pressure. Right? So at particular point, if I want to fix up a coordinate, so this is 1, and this point is say 2, right? So at particular point P1, so here the pressure is P1 and this is P1, right? And here this is pressure is P2 and the volume is V2. So this is the coordinate. In the mathematics we are writing as P1 V1, the coordinates at P2 V2. So with this condition we are knowing that at state 1, so the mass or the gas, whatever it is there, it has got a pressure P1 and volume V1, P2 and V2. So these are all the intensive properties, and it tells about the condition of that particular at that particular point. So that's why properties, you can say, are called as state functions. It is a state function. It does not depend upon the path. It depends upon particular state. So the state 1 and state 2. At any point of this one, so these states, that any state, the pressure will different and volume will be different. So that's why properties are the state functions. Try to remember this. Okay. So as I said, in the properties there are two things. One is intensive property and the other one is the extensive property. Intensive properties are one which depends upon mass. It does not depend upon, mass. So for example, if you take temperature, pressure, So these are all intensive properties. As an extensive property is one, it depends upon the mass. Say for example weight, if you take it. So weight, it depends upon the mass, right? Weight is nothing but the force. In case of MKS unit, we are calculating as kilogram force. In SI unit, it is called as newtons, right? So a force is nothing but a newton. So now it depends upon the mass. It depends upon the mass. Hence, it is an extensive property. Are you getting it? So like this, you try to find out which are the dependent intensive properties and extensive properties. Okay. So after this, now I will not go in deep what is exact differential and inexact differential, so that if you want to further, you can go through some books are there. Pikenag or Balani, you can write. You can go through that book. You can find out which is the exact differential. Exact differential is the property of a system. So now the second one, we will go for the other one is the path function. So as I said earlier, properties are state function. Whereas if you take work done or heat or flow work, anything, energy. See, what are these things? Energy, it may be an entropy, enthalpy, internal energy. So work done, heat, flow work, this energy. So these are depends upon the path. The path followed by the states. Each successive states, if you join it, so that becomes a path. So let us say, if 1 is this, 2 is this one. If I want to go from 1 to 2, I can take a path like this, right? Or the second path, I will take this one. This is path A, let us say, I will call it. And this is the path B. And let us say this is the path C. And now, the area under the curve, before going for this one work done, etc. The area under the curve PV diagram. P is what? It is Newton per meter square. And volume is in meter cube. So, Newton per meter square into meter cube. What you will get? Newton meter. Isn't it? So, what is Newton meter? It is a work done. It is work done. Okay. Or energy unit. It is nothing but an energy unit. So, the work done in PV diagram, it is nothing but the area under this curve. Area under this curve, if you integrate it from by taking a small element of this strip here, this is dV, to 1 to 2, V1 to V2. So then I can get the area under the curve, we can get it. Right? So this is the work done in the process of A. That is work done. It is not integration work. Work done from V1 to V2. It is pressure P into dV following the path A, is equal to area under the curve, what I have shown here, right? The other one, the area under the curve path B, if I take it, so then it will be again the curve, if I join it like this, so this area we can get it. Are you getting it? So this integration of V1 to V2 and points are same, but paths are different. The path followed is B and this is PDV. Okay. So now you just note down the thing that the area under the curve B is more than the area under the curve A. So hence, the area under the path A is less than the area under the path B, and which is again it may be less than the area under the path C, isn't it? So that's why we are saying it depends upon the path, whether work is done on the system or work is done by the system. Work is done by the system, we are saying here it is a positive because it is an expansion. So here V1 is changes to V2, so it is an expansion work. So that's why work done is a positive. If on the other hand, if this thing it goes like this, so it is a compression, work is done on the system. So that's why in that case it is negative. So really the thing is that it is a convention whether it is work done by the system or work done on the system. It is not less than 0 or more than 0. It is the quantity, you know. So that is it is in joules, whether it is 120 plus or 120 minus. So always it is Newton meter only. That is the energy. It is done on the system or done by the system. That's all. Okay. So like this, heat is also it is interpreted in the same manner, and energies also it is in the same. So the internal energies, it is represented by almost U is equal to U or delta E. Sometimes it is we are calling it as delta E as an internal energy. Listen, right? Or it is delta U. Okay, this is internal energy. Delta means very small difference of U2 minus agar U1 area. So in that case it is called small difference of delta U, the change in internal energy from state 1 to state 2. Okay, so if U2 is more than the U1, so in that case U2 minus U1 will be positive, right? So that's how that is increase in the internal energy. That means addition of heat if it is there. So definitely there is an increase in the energy is there. If extraction of heat is there, so definitely there is a reduce in the internal energy is there. If work is done on the system, if it is there, so definitely there will be an increase in the internal energy. If work done by the system, in that case, so the internal energy it will be reduced. So that thing you can learn it in the first law, second law, thermodynamics. So that's just to remember this at this point. What is property, state point, and this the another one extensive properties depends upon the mass. Okay, and now enthalpy, entropy, or enthalpy is there, heat is there. It is an extensive property, right? And this is it depends upon the mass as well as it depends upon it is a path function, whereas intensive is a property, it is a point function, right? State function or the point function, it is a property, and path function it is an extensive property, or the flow work, heat, work done, everything, whatever you will get it is an extensive properties. So now let us, we will go for the second point of our discussion. So just I have discussed what is pressure, temperature, volume and density. Intensive and extensive properties we have already discussed. Now we will go for the system, subsystem and control value. Okay. So a system is one on which the study is focused, right? You take a particular system in a power plant engineering. And so in the power plant, you are knowing this is a boiler. From the boiler, it goes to the turbine. From the turbine, it goes to the condenser, right? And then condenser, the condensate, whatever it is there, it is used in a pump. Again, you are feeding this fed condenser to the boiler. Okay, this is the thermal power plant. Basic units of thermal power plant. In that, if I take a boiler as one unit, so if you take a boiler, I will designate that as boiler as B. So what you are adding here? We are adding Q. So as I said, the boiler, in the boiler, it is a fixed one, boundary line, and there is a transfer of heat is there. Feed water goes inside and steam is coming out. So this is how we are going to get a superheated steam by adding heat to the system, right? So if I take this particular system as working, so this is the surrounding and this becomes a system. So is it a closed or open system? So it becomes an open system since there's a mass transfer is there. Mass transfer is there, right? So that's why it becomes an open system. The energy, there are two things. One is the mass transfer, mass, and the other one is the energy. So energy transfer will be there always across its boundaries. Across its boundaries. Either it goes from the system to the surrounding or surrounding to the system. Maybe or may not. Our mass will be there. If the mass crosses the boundary from system to the surrounding or surrounding to the system, so then it is called open system. If mass does not cross the boundary, it is called closed system. For example, in a closed system, we can have a this one. That example I will take it as a cylinder is there, and let us say you take a piston or a nut, right? So that there is no mass transfer across it, and this is some gas will be there, trapped gas, and we provide the heat to this. So there is an expansion takes place, and thereby this piston it moves up to the new position, right? So here there is an expansion of work is there. So this boundary, it is not a fixed boundary, it is called moving boundary. Moving boundary. So whereas this was a fixed one, this is a fixed boundary, and here it is a more moving boundary, because as you add the heat, the piston goes up, and thereby this volume will change. The boundary, initial boundary is this, and the final boundary will be like this, right? So that's why the moving boundary, this is the imaginary surface we have drawn. So this is a closed system. So there is no mass transfer across it. So this is an example of the closed system, right? So if P is the pressure inside this, and if dA is the area, so what you will get? Pressure into area, pressure into area, you will get a force, right? Force into the distance, if I take this as delta L, is the change in the distance. So P into A into delta L, what you will get? So this is pressure into volume. A into delta L is volume, right? So that is V. So this is called flow work. So when you add heat, due to the heat, so that volume will be expanded, and that with the same pressure, whatever the pressure is there, the volume will change. That is the flow into work. That is a PV. It is a flow work, and the units of that is Newton meter or Joule. Okay. So this is it intensive or extensive? It is an extensive property because it depends upon the force. Because force depends upon the mass. Okay. So this is a path function. It's a path function. It depends upon the path followed. So whether the expansion it is carried out with the same, the outside atmosphere, outside is the atmospheric pressure, against the atmospheric pressure if it is expanding, and that is constant, in that case we can take it as an outside. So this is a system, closed system, and you have learned what is the open system. And now about the control volume. Control volume. So just it is an imaginary boundary. As we are drawing the imaginary boundary. So this is also an imaginary boundary drawn to show some, says there is some boiler or turbine is there, right? This is the inlet, the work output, that is the work done. Okay, steam inlet, steam outlet. If you take turbine, so in that case I can make a control volume across it. Right? It is just a surface across its system, and within this one we are just working on that. So what changes happens if I add heat to this, or with the same steam pressure, high steam pressure, if it expands, in a where is that, in a turbine. So there the expansion, there is a drop in the pressure will be there, that is transfers to the kinetic energy, and there you will get the work output. That is the work done, you are going to get it, right? So if I draw the control surface over this, so this is control surface. Okay, and usually it is drawn in the open system, not for the closed system. Okay, I think this is sufficient for to know what is open system and closed system and isolated system. Isolated means there is no change mass or the energy. So no energy as well as mass is transfers across its boundary. That is completely isolated. Or any system with a subsystem, it is known as isolated system. If I take this in a thing, if you take a power plant, if the whole thing, if I take this is a surrounding to that, and if I take this as a universe, this is a thing, as a system, And in this system, this is an isolated system. Turbine is an isolated system. Any subsystem of a system is an isolated system. Okay. Any subsystem of a system is an isolated system. Isolated system is one. There is no heat and mass transfer. Heat, work, or mass transfer across its boundaries. Say for example, a perfect thermos flask, if you use it, thermos flask, right? It is adiabatic valve, there is no heat transfer. If you take a perfect one, so no heat transfer across its boundary, nahi hoga heat transfer, and no mass transfer. Mass transfer is also not there. So in that case, so this is an isolated system. Completely isolated from the system or from the surrounding. So there's no interaction between the system and the surrounding. So that kind of a system is known as isolated system. Okay. So like this, you try to find out what are the different. If you take a cooker is an example of open system. Thermos flask, it is, if it is an ideal thermos flask, it must be an isolated system. Okay. And like this, you try to identify the different components and try to learn more of this one. Okay. So in the next class, I'm going to, we are going to learn the review of first law, second law, and the other laws in thermodynamics. Okay. So thank you. So in the part 2, you have learned this one. In the part 3, we are going to learn what is the zeroth law of thermodynamics, first law of thermodynamics, and second law of thermodynamics. Okay. Thank you.